Okay, in this video I'm going to discuss the concept of the highest common factor, and the highest common factor is simply named as HCF. Okay, so highest common factor. So when we speak of highest common factor, we're talking of at least two numbers. So let's say I have the numbers 18 and 30. If I want to find the highest common factors or highest common factor of 18 and 30, then all I have to do is to identify the factors of each number. Like for 18, 18 is 1 times 18. 18 is also 2 times 9. 18 is also 3 times 6. And yeah, that's it. Basically, those are the combination of numbers that will produce 18. So the factors of 18 are 1, 2, 3, 6, 9, and the number 18 itself. And then I look at the factors of 30. So I'll think of two numbers. If I multiply them, they become 30. So 1 times 30. And then that's also by 2. 2 times 15. I know it's also by 3. 3 times 10. Not 4, but maybe 5. 5 times 6. And then I think that's it. Okay. So I have 1. I have also 2. I have 3. I have 5. I have 6. I have also 10. I have 15, and it's the number itself, 30. So to find the highest common factor, by the name suggests, you look for the highest, the biggest, and also common. So same with the two numbers, as a common factor. So if I inspect the factors of 30 and 18, so they have the same one. Both of them have 2 as a factor, also 3, also 6, and then not 9, not 18. So the highest common factor is the biggest of the numbers that I encircled, and that is 6. So the HCF, or the highest common factor, of 18 and 30 is 6. So that's how you find the highest common factor. This particular method that I use is what we call the listing method. Okay, so this is the listing method. Now, if you notice, the listing method requires you to really be good at knowing the factors of the given numbers. Like I should know that 18 is 1 times 18. I should also know that it's also 2 times 9 and 3 times 6. Same with 30. And sometimes getting the numbers or the correct combination that will be that will give us a product 18 can somehow be, juice if the numbers are big already, or you might miss a factor. Okay, so aside from the listing methods, I'll introduce another method of finding the HCF, and that is the use of prime factorization. Okay, so let me explain the idea behind the second method. Okay, so we'll use the same numbers 18 and 30. So how do I get the prime factors of 18? So I have 18. I can produce a tree diagram. So I know that 18 is 2 times 9. So try to break down 18 into two numbers, in which use small numbers like 2 or 3 first. Because the moment you divide 18 by 2 or by 3, then the new number will become smaller. Like 9 is already much smaller than 18. And then, so since 2 is already a prime number, so I can leave that now. Then work on the 9. And 9 is the same as 3 times 3. Note I didn't use 2 because I know that 9 is an odd number. So I use the next prime number, which is 3. So, which is actually, most people will know that 9 is equal to 3 times 3. So from here, so we have 18 to be expressed as a prime, in terms of its prime factors, as 2 times 3 and then times 3. So again, this method that we use here to break down 18 is what we call the prime factorization. So we're breaking down the number 18 into its prime factors. Okay, and then let's just leave that for the meantime and work on the second number, which is 30. So we'll apply the same. So I know 30 is an even number, so I break that into 2 times something, which is actually 2 times 15. And then break 15 into 2 factors, you have 3 times 5. So 30 can be expressed as, so we have 30 can be expressed as 2 times 3 and then times 5. Now once you have the numbers written into their prime factors, so all you have to do is to list them down in a special manner. So 18 is 2 times 3 times 3. And then 30, try to align the factors of 30 to the factors of 18. So I have 2 and then I have 3. But since the last factor of 30 is 5, so I'll skip the space below 3 and then I'll write 5 here. Okay, now to get the highest common factor, this technique will just require you to drop the common factors. And this is 2, and this is also a common factor 3. Okay, and finally, the highest common factor is the product of 2 and 3, which is 6, which is consistent with what we obtained a while ago from the listing method. Remember, we got the highest common factor 6 from the listing method, and now using the other method, we were able to find the HCF, which is also 6. Now you can extend the idea of HCF even if 3 numbers are given. Say I can have, let's say example only. So 42 and then let's say 56 and then let's have maybe 84. Okay, so I'll break these numbers into their prime factors. So let's start with 42. So I know 42 is 2 times 21. 21 is 3 times 7, and in which 3 and 7 are already prime numbers, so we can have 2 times 3 and then times 7 with 42 in terms of its prime factors. And then let's work on 56. So 56 is 2 times 28. Okay, and then break 28 into 2 factors. You select 2 again, and this is 14. And then 14 is 2 times 7. Okay, so 2 and 7 are prime numbers, so we can stop there. So we have 2 times 2 times 2 times 7 for 56. And then we work on the last number. So we have 84. So we break down 84 into 2 numbers first. So we have, let's divide it by 2, and this is 42. 42 is the same, so half it again because it's an even number. I have 21, and then 21 is 3 times 7. So 84 is actually 2 times 2 times 3 times 7. And you can always check these numbers if they really multiply to 84, to 56, and to the first number, which is 42. Okay, so the next thing that we need to do, so we'll make that special alignment of factors. So we write 42, I have 56, and I have 84. So let's get the factors of 42. I have 2 times 3 times 7. For 56, I have 2. And then there's another 2, but 42 doesn't have, it only has 1 2. So we skip some space, so times 2. And then another times 2. Then the final factor to be times 7, but there's a times 7 in 42, so I'll align that here. Okay. And then for 84, I have a 2, and then another 2, so I align that with the 2 for the second to 56. I have times 3, so there's a 3 on the 42, so I'll align that here, and then times 7. And to get the highest common factor, all you have to do is to drop the common to all three, not just 2. Okay, so you have to consider only the numbers common to all. Okay, so I have 2. I don't consider 3 because 56 doesn't have 3 as a factor, but 7 can be used, so this is times 7. I can't use the second 2 and also the last 2. Okay, so basically we only have 2 and 7 common. So these are the only common factors for 42, 56, and 84. So don't consider this, this, and this. So the HCF is the product of 2 and 7, which is equal to 14. So 14 is the highest common factor of 42, 56, and 84. Okay? So I hope you're able to understand my explanation of getting the highest common factor. And we were able to identify 2 methods in finding it. The first one to be, if you just have to list the factors of the numbers, we call it the listing method. And then the second one, we make use of prime factorization and then try to get the common factors of each number and multiply those common factors to get the highest common factor. Okay, so that's it for now. So again, if you find something here confusing, sometimes reviewing or have the video play again will help you to understand the ideas. Okay, so that's it.